Okay, today we're going to talk about nth roots and how they pertain to rational exponents. So, we've all seen x cubed before, x to the third power. How could we write that out if we wanted to write it as an expanded expression as opposed to with an exponent? Well, basically, what does it mean? So x cubed means we're multiplying x by itself 3 times, right? Hopefully we're all familiar with that. The question that I want to pose to you next is, what would x to the 1/2 be? So what if that number that we're raising it to, what if that exponent is a fraction, and what if that fraction is less than 1 specifically? Hopefully you know, and if you don't, that's okay. X to the 1/2 means the square root of x. So fractional or rational exponents mean that we're going to be finding roots of varying types, and we're going to talk more about what some of those might be here in a second. So x to the 3/2. Well, we know that the halves means it's a square root of x. So what do you think that 3 does? Well, if x cubed means that there's 3 x's, there's still going to be those 3 x's. It's just that they are inside the radical. And you could write that this way or like this. Either one of these works. Okay, so x to the 4/5 means that we are taking, oops. Oh, come on, there we go. A root of x. We want the 5th root, and we're going to raise the entire thing to the 4th power. Okay, so the numerator, let me change colors. The numerator tells us which power to raise the radical expression to, and the denominator tells us the index of the radical. So I want to do a little bit of vocab here real quick. We've got a big radical. The stuff that goes on the inside is known as the man, this pen is still not working. Radicand. The index is the number telling us which root we're taking. This entire thing is what we refer to as a radical or a radical expression. So, write as a base with a singular exponent. So if I'm taking the square root of 5 and raising it to the 3rd power, I want just a singular exponent, so just one exponent instead of a radical and an exponent. So that's going to be 5 to the 3/2. Right? So I'm going to take the square root, meaning I need to have a 2 in the denominator of my exponent, and since it was cubed, 3 needs to be the numerator. This one would be 10, that's not a 10, to the 4/5. This would be 4 to the 2/4. This would be 27 to the 4/3. Then it says to evaluate each expression using a calculator. So to evaluate something like this with a calculator, you're going to type in 5 to the, so that's that caret button on a graphing calculator. It's right above the division symbol. Your phone should have it also. Open parentheses, 3 divided by 2, close parentheses. Those in parentheses are important. Otherwise, you're going to end up raising it to the 3rd power and then dividing that whole thing by 2, which is not the same as raising to the 3/2. So 5 to the 3/2 should be approximately 11.18. Okay. So then for this one, 10 to the 4/5. Again, I'm going to type 10 to the 4/5. And I'm going to put the 4/5 in parentheses. 10 to the 4/5. I'm typing it in my calculator, and I'm getting approximately 6.31. Now over here we can simplify a little bit before we use the calculator. 2/4 is just 1/2, so that's just 4 to the 1/2, which means the square root of 4. Well, what's the square root of 4? It's got to be 2, right? We don't even need a calculator. We can do something similar down here if we think carefully. So I need the cube root of 27. That's what this thirds means. So cube root of 27, I know is 3. So really that's just 3 to the fourth. I can look at that as order of operations. If I find this first and then raise it to the fourth, I can do it without a calculator. So 3 times 3 is 9, times 3 is 27, times the fourth 3 is 81. Okay. So go ahead and check those with the calculator to make sure you're typing stuff in correctly. I'm going to go ahead and move on. If b to the nth power is equal to a, then we would say that b is an nth root of a. For example, 5 cubed is 125. So I could say that 5 is a third root or a cubed root of 125. I don't know what's wrong with my marker, guys. I'm very sorry. I'm going to restart the marker while I keep talking. So if any power of b gives us a, we can say that b is an nth root of a, and that the n gets replaced with whatever our power is. So if it's 7 to the 13th equals something, then 7 is a 13th root of that something. Okay. So this is going to be the sheet that you're definitely going to want in your notes. So let's say that n is any integer greater than 1. It's important to note that. All right, so let's say, oops, I want blue and I want it to be small. Let's say this is important. N is bigger than 1. So it's not negative and it's not a fraction. And let a be a real number. So positive, negative, fraction, decimal, whole number, doesn't matter. If n is even, and a is negative, then there will be no real roots because we're taking the square root of a negative number, right? Because it's an even number. So square root, fourth root, sixth root, you can't have negatives in there. If it's equal to 0, then there's only 1, and it is 0. If it's bigger than 0, you're going to have 2 roots, plus and minus a to the 1 over n. If n is odd, if we're taking an odd root, it can be negative, and there will just be 1 real root. If it's equal to 0, then there's just 1 and it's 0. And if it's greater than 0, then there's only 1. And you'll notice these two are the same. It's just that they're going to be different signs. So if I'm doing like the cube root of negative 8, that is negative 2. Negative 2 times negative 2 times negative 2 gives me negative 8. If I'm doing the cube root of 8, then that's just 2. Right, so notice that whatever a is going to have the same sign as our root, if and only if the root we're taking is odd. If the root that we're taking is even, it can't be negative or you won't have any real roots. Go ahead and pause this and make sure you get this little table copied into your notes. It's going to be very helpful for you as you move forward. So find the indicated nth roots of a. So if a is 216, I'm looking for the third root. So this is what it's asking us to do. Okay. So if you don't know what the cube root of 216 is offhand, that's okay. In a calculator, you can type negative 216 to the parentheses 1/3. Notice that I put parentheses around the negative 216. If I don't, the calculator will do 216 first and then just give me a negative answer. So we want to make sure to keep everything grouped. So negative 216 to the 1/3. I wish I could show my calculator screen to you. Gives us, I'll wait for you to come up with it if you're doing it, negative 6. I want the fourth root of 81, so I'm looking for the fourth root of 81, or 81 to the 1/4. That one, I hope we might be able to know because we just used it a little bit ago, but 81 to the 1/4 on the calculator, that's going to be 81 to the 1/4. You could type that as a decimal. It could be 81 to the 0.25. That would also work, but we should be getting 3. I hope we're having some success typing these into the calculator correctly. There is no way to tell a calculator to do this, but we can absolutely tell a calculator to do that. So that's one of the biggest benefits of writing it in with a rational exponent as opposed to a radical symbol, is because we can tell computers and calculators what to do with that much more easily. I'm going to make this a yo-yo, so take a second, pause this. You're on your own. I want you to pause for, let's see, whatever, 30 seconds, a minute, whatever it takes for you to punch both of these into your calculator, or do it by hand and get the roots. So pause and go. Okay, we want the fourth root of 16. So that's the fourth root of, of 16, or 16 to the 1/4. Hopefully, we all got 2. 2 to the 4th power is 16. Then I want the cube root of negative 125. I used this as an example earlier, negative 125. So that's negative 125 to the, remember in parentheses, 1/3. And we should get negative 5. If I take negative 5 and multiply it by negative 5 and multiply that by negative 5, you'll get negative 125. Okay, this looks like a lot, and it's a lot more confusing looking than it actually is. So just bear with me just for a second. Let's let a to the 1 over n be an nth root of a, and let m be a positive integer. Okay, so if I have a to the m over n, we're just showing that this can be rewritten as the nth root of a and raise that whole thing to the mth power. Now the difference is, what if that exponent is negative? All it means is that this same expression has to go underneath the 1. Just like we said that x to the negative 2 has to be 1 over x squared. That's exactly what we're doing here. If I gave you x to the negative 4/7, that's just 1 over the 7th root of x, and we're raising that whole thing to the 4th power. So a negative exponent still just means we're dividing by that expression. It needs to go in the bottom of a fraction. So if you get something like these and it says to, whether it's evaluate or just rewrite using radicals, this could be the square root of 16 to the 3rd power. Now let's evaluate that. What is the square root of 16? I know what that is. That's just 4 cubed. So 4 times 4 is 16 times 4 is 64. So 16 to the 3/2 power is 64. We can do the same thing here. This is the 5th root of 32 to the 3rd power. But since the exponent was negative, we need to put that entire thing under a 1. Okay, so can we figure out the 5th root of 32? So on a calculator, you could do 32 to the 1/5 or to the 0.2. You should get 2. 2 is the 5th root of 32. So that's 1 over 2, but that cubed is still there. So 2 cubed, which is really just 1 over 8, or 0.125. So we could skip straight from this all the way to there just by some simplification. So if you see something like this and it says to simplify or to write as an expression or to evaluate, this is the process we're going to take. Write it as a radical, see if you can simplify the radical, and then raise whatever that result is to the given exponent. Okay, you're on to homework. Good luck.